Hello, ladies and gentlemen. Today we're going to talk about arc length and area of a sector. So this still has to deal with our circles. You're definitely going to want something to write with. In your notes, you're going to have to write down all of these examples on your own notebook paper. And you're definitely going to want a calculator. So let's get started. So in today's lesson, we will use our area formula and our circumference formula. So making sure that if you don't already have those memorized, that you have your notes from previous lessons to help you kind of guide through how to use these formulas, because today's lessons rely on us already knowing how to use these formulas. So if we jump forward here, it's important to note that although we do see circles a lot, we're not always only concerned about the whole circle. Sometimes we look at just chunks of it. For example, in a pie chart, we might just look at this green section here, or with a piece of pizza. We just think about the area of that pizza or how much of the whole pizza you've already used. Okay, so as we move forward here, today we're going to talk about not the whole circle, but pieces of those circles. So some vocabulary you're going to want to jot down before we jump ahead. We have what we call an arc. So an arc is just a piece of the outside of the circle or the circumference of the circle. We then also have a sector, and a sector is what you would notice it would be your piece of pizza. So that would be a chunk of the area of the whole circle. And then we have a segment. So it's not necessarily a piece of pizza, but maybe just focusing on part of the crust of a piece of pizza. But these are three big vocab words that we talk about as we move forward with our circles. So making sure that you understand, okay, an arc would just be on the edge of the circle. The sector is part of the whole circle, which would be like the inside included, and a segment, again, would be considered like the crust of our pizza. So not necessarily using the inside of our circle with degrees, but just taking that outer piece of it. We also then have what we call major and minor sectors. So the major sector here, we consider a major sector when it uses more than 180 degrees. So that's the same thing for arc. So that we call it a major arc if it's greater than 180 degrees. Likewise, then on the other hand of things, then when we talk about a minor arc, those are going to be anything less than 180 degrees. So same thing here, minor arc. This is when we talk about anything less than 180 degrees. Or the minor sector would be less than half of your circle, and a major would be more than half of your circle. So again, just getting these pictures jotted down with some vocab words connected to them, so that way when we jump forward and I use our vocab, you know what it is that I'm talking about. So an example of where we might use today's lesson is if I were to give you the minute hand clock. It has a radius of 12 centimeters. I would ask a question like, in centimeters, how far does its tip move between the times of 11:55 and 12? So after today's lesson, we will be able to solve this given example. If you wanted to take a second to try and solve it before we moved on, you could try that. But by the end of today's lesson, you should have enough knowledge to help you get through this specific example. So the first thing we're going to talk about then today is our arc length. So we have two different formulas here. Essentially, the formulas are saying the same thing. Arc length, again, is just the outside of our circle. So it's just an outer piece here. And when we think about a circle and we just talk about the outside piece, we know that as our circumference. So when we compare that little chunk, we're going to compare that arc length to the circumference as a whole. So when we find arc length and we find the sector area, which is what we'll find next, we use a proportion. So again, we're going to use the measure of the arc, and the arc is always going to be the same as this interior degree here as well. So since this outside one is 70, we can know that the inside one is 70 and vice versa. So depending on where they give you that angle, you know that as long as it's formed by two radius and it's in the center of your circle, the arc length and measure is the same on the outside as the interior angle there. So when we set up this proportion, we set up the measure of the arc, which is just our little chunk, compared to the whole, which is 360. That has to equal the same ratio of the arc length, so just this chunk of the outside compared to the whole outside. So again, You don't have to necessarily write down this one every time, but the second one here, instead of writing circumference, we know the formula of circumference, so I've just replaced in this second formula 2 pi r instead of writing circumference. So this bottom one is the one that I'll use most of the time just because it already has that equation for the circumference in there already. But again, this is how we're going to set up solving for arc length. So if I go over to this first example here, we want to find the length of the indicated arc. So what I have highlighted kind of in green here. So we're going to use this same exact formula over here, and we're going to plug in for what we know. So the measure of this given arc is going to be 70 degrees over 360. Now arc length, again, this is what I'm trying to find here. So that's going to be my unknown, and for unknowns we plug in the variable x. And then I have 2 pi r. So instead of writing 2 pi r, since I know what r is, down here it tells me that r is 4 centimeters, I'm just going to plug in the 4 right away. So now this just becomes a proportion, and when we've done a lot of work with proportions here, we just know that from here I have to cross multiply to solve. So I'm going to simplify the left-hand side. I'm going to cross out those zeros so I have smaller numbers to work with, and from there I'm going to cross multiply. So 36 times x would give me 36x equals, now I have 7 times 2, but the 2 is also being multiplied by 4. So I have 7 times 2, which is 14. And when you take 14 times 4, you should get back the number of 56. So I'm leaving pi involved now because I don't want to have to type in any decimals until I get to my final answer. So I'm leaving the pi in there until I'm trying to solve for my very final answer. Now again, we're trying to solve for x because that's my arc length. So on both sides, I'm going to divide by 36. And now this is where I would want to grab out my calculator. So I'd grab out my calculator, type in 56, hit the pi button, or if you were using Desmos, you can use Desmos, hit the pi button, and then you're going to hit divided by 36. When you type that into your calculator, you should get back the number 4.886 or something, but that 8 rounds up to a 9. So the arc length that we just found here would be 4.89, with a good label would be centimeters. So again, up until the point of typing in your calculator, leave pi in there until the very end when we're trying to find our final answer. Before then, you're just going to be rounding too many times. So for this first example, again, the arc length that we found is 4.89 centimeters. So now we're finding sector area. So when we're finding sector area, again, area is like a shaded region. So this is this whole chunk. This would be like our piece of pizza that we're trying to find. It's a very similar formula, except now since I'm finding the area, I wanted to use the area of a circle formula, which would be pi r squared. So we're going to go about it the same way. I'm going to use the same pieces of information, plug in for what I know, and then essentially in the end I cross multiply to help me solve. So again, we want to find the area of the sector. So let's plug in for what we know. The measure of the arc is 70 degrees over the whole, which is 360, equals the sector area. Again, that's our unknown. That's what we're trying to find. So I'm going to plug it in x over pi r squared. And again, I know my r right off the bat, so I'm going to plug it in. Pi r squared. So again, on the left-hand side, I'm going to cross off these zeros, make these numbers a little bit easier to work with. 36 times x would be 36x equals, now in the bottom here I have 81 pi because 9 squared would be 81. So I'm going to type in my calculator 7 times 81. When I type that into my calculator, I get back the number of 567. Again, I'm ignoring the pi for now because I don't want to have to plug in pi or round any decimals until I get to my very final answer. So I have 567 pi. From here again, let's divide both sides by 36 because we're trying to get that x alone. And now comes the point where I can grab my calculator out and type it in. Again, you want to type in 567, hit the pi button, and then divide by 36. When you do so, hopefully you get back the number 49.48. I would make sure that you are doing it with me, even though sometimes you may not, because that way you know at least you're using your calculator correctly for when you jump in and try to do your assignment. So again, since we're finding area, I am going to have a good label of centimeters squared. So this chunk of pizza, this chunk of the circle, has an area of 49.48 centimeters squared. Again, a lot of this is just using your two formulas, knowing which one you're using. Am I using it to find the arc length, or am I using it to find the sector area? Plugging it in and then cross multiplying. So in this example, we want to find the area of just the shaded segment. Again, the segment is just like our crust. So looks like we're going to want to have to find the whole area. If I were to find the whole area here, and this is just me thinking through a way to solve this, I can find the whole area of this whole shaded region. I could then somehow find the area of just this region, this little triangular region, and then I could figure out what that piece is by taking the two of them and subtracting them. So what my goal here then is, the first thing I'm going to do is I'm going to find the area of the sector. So in order to do that, again, you use your formula, which would be the arc length. Again, here I have a 90 degrees, so the whole arc here has to be 90 degrees. For the whole circle then is 360 equals the area of the sector is what I'm trying to find. So that'd be x over pi r is 6 squared. So again, I'm going to simplify this. 9 actually goes into 36, so this all simplifies down to 1 over 4. And then I'm going to cross multiply. So it looks like I'm going to get 4x equals 6 squared would be 36 times 1 would be 36, so I get 36 pi. To solve for x, I divide both sides by 4. X is going to equal 36 pi divided by 4 gives me the number 28.27 centimeters squared. So that is for the whole sector here, this whole chunk of my pizza. Now I want to eat the good part of the pizza and just leave the crust. So if I were to find the area of just the good part of the pizza, notice that that shape is a triangle. So in order to find the area of a triangle, we have to remember that the triangle is base times height divided by 2. So look at the base here. Again, this base is a radius of our circle, which we know is 6. And then the other side here is another radius, so that's 6. So the base and the height are both 6. So I can plug in 6 times 6 all over 2 to get 36 divided by 2. So the area of our triangle is going to be 18 centimeters squared. So to find just the crust, I can take the whole pizza, the whole piece of pizza. I can subtract the 18 centimeters squared that I ate of the pizza to get back a number. If I were to just type out those steps, and then when I do that in my calculator, get back a number, the area of just my crust, or the segment of this circle, or this sector, is 10.27 centimeters squared. Again, if I went too fast, slow me down, pause as I'm talking, and make sure you jot down any questions you might have so we can address those when the time comes. So the last example we're going to talk about here is, if given an arc length, could you find another piece of information? So our goal in this example is to find the radius of this circle. So since we're given that the arc length is 4.9 inches, we are going to want to use the arc length formula. So the arc length formula is the degrees of the arc, or the measure of the arc, over 360 equals the arc length over 2 pi r, or the circumference. So this r right here is what we're going to want to try and solve for. Everything else we should be able to fill in. So if I go about filling it in, the degrees would be 40 over 360, and the arc length I'm given is 4.19 over 2 pi r. So again, I'm going to try and cross multiply to help me solve this. So I'm going to simplify this side. 4 actually goes into 36, so that's going to actually simplify down to 1/9. Now when I cross multiply, I get 2 pi r times 1 equals 9 times 4.19, and when you type in 9 times 4.19, you should get back 37.71. And from here now, I just want to solve for this r, so I'm going to get rid of everything else. Remember, pi is just a number, so I'm going to divide this whole thing by 2 pi. 2 pi. Now you can type this directly into your calculator, but make sure you use parentheses around that 2 pi. So when you type that into your calculator, you should get back a value, 37.71 divided by, in parentheses, 2 pi. You should get back a value of 6.00 inches. So the radius comes out to be an even 6 inches. So again, if any of that problem doesn't make sense to you, make sure you star it. You write down a question you have specifically for me, and we can address that when we meet. So I want to thank you for taking good notes, and I will see you when I see you.